Welcome to This Day in His Story, created by American Heritage Worldwide, a reminder that every day holds something new to learn. Did you know that the word vernal is a Latin word meaning spring, and equinox is a word that means an equal amount of night and day? Learn that the first day of spring, or the vernal equinox, has exactly 12 hours of daylight and darkness, and that during the equinox, the sun rises due east and sets due west, everywhere on Earth. Discover that the equinox happens at the same time worldwide, and that the Earth takes one full year to orbit the sun, giving us all 4 seasons.
Before you even look at a calendar, there's this subtle shift that happens in the environment that tells you the seasons are turning.
Oh, absolutely. You can just feel it.
Yeah, right. Like you step outside and maybe the angle of the light hitting the pavement was just a little bit sharper, or, the air might still be freezing, but that heavy sort of stagnant feeling of deep winter has kind of lifted.
It's like your brain registers this environmental data before you even consciously process it.
Exactly. And that instinct is highly relevant to you today, because today is Wednesday, March 18th, 2026, which means we are standing right on the precipice of the vernal equinox.
It really is one of the few astronomical events that genuinely intersects with our daily physical experience.
Yeah.
I mean, we spend so much time insulated in these climate-controlled environments, right? But this is a moment where the planetary mechanics become just impossible to ignore. The Earth is shifting its posture.
Shifting its posture, I like that. And that brings us to our mission for this deep dive.
Yeah.
Because we have your notes right here, and it's a really fascinating stack of sources covering the hard science of our changing seasons, the incredible ancient monuments built to track them, and the centuries of spring folklore that followed.
It's a lot of ground to cover.
It is. So our goal is to extract the absolute best nuggets of insight from this material. Consider this your shortcut to being fully well-informed about the arrival of spring. Understanding not just that it happens, but the actual mechanics of why it happens.
Well, to really grasp the magnitude of it, I think we should start with the terminology itself. Because humanity has been tracking this for, thousands of years.
Oh, for sure.
And the language we use carries the weight of all that observation. If you look at the Latin roots, vernal translates simply to spring.
Right.
And equinox comes from equus, meaning equal, and nox, meaning night. So quite literally is the spring equality of night and day.
Okay, let's unpack this. We say equality of night and day, which, it sounds incredibly poetic, but it's actually a rigid mathematical reality based on our orbit, isn't it?
It is. It's a strict geometric equilibrium. The vernal equinox marks the exact midway point in our orbital cycle.
Right, between the extremes.
Exactly. Between midwinter, which is the darkest day of the year, and midsummer, our longest, brightest day.
Okay.
So for this fleeting window, the entire planet experiences a balanced distribution of sunlight. We receive about 12 hours of darkness and about 12 hours of daylight.
I always picture the equinox as the planet taking this massive collective deep breath.
Oh, that's a good way to put it.
Yeah, it's like the ultimate cosmic reset button. For this one specific moment, the scales are flawlessly balanced before we inevitably, tip over into the long, hot days of summer.
And that analogy of the scales is entirely accurate in an astronomical sense.
Is it?
Oh, yeah.
Yeah.
Because from this day forward, the length of daylight is going to slowly, incrementally increase for the Northern Hemisphere every single day, right up until we hit the summer solstice.
But to understand the why behind this 12-hour balance, we need to, step away from our human calendars and look at the solar system from a top-down perspective.
Right, getting out of our own bubble.
Exactly. Because we experience this as just a gentle warming trend in our local weather, but the cause is its massive planetary mechanics.
Yeah, and what's fascinating here is that the primary driver of this isn't just our orbit around the sun, it's actually our tilt.
Okay, the tilt.
Right. So the Earth takes exactly 1 year to complete a full orbit, but our planet is tilted on its axis at roughly 23.5 degrees.
Which is pretty significant.
It changes everything, because if we were standing perfectly straight up and down relative to our orbit, we wouldn't have seasons at all.
Wow.
Every day would be an equinox. But because of that tilt, different parts of the globe lean toward or away from the sun at different times of the year.
Which creates this perfectly mirrored experience across the globe. Because according to your sources, while we in the Northern Hemisphere are watching the ice melt and looking for the first buds of spring, the Southern Hemisphere is simultaneously experiencing the start of autumn.
And fast forward a few months, the peak of our summer will be the dead of their winter.
It's crazy to think
It
about.
really is. And the equinox is that transition point. It's the moment when the Earth's tilt is entirely perpendicular to the sun's rays. We are leaning neither toward the sun nor away from it.
And this brings us to a geographical fact from the sources that honestly requires some serious spatial reasoning.
Oh, you mean the due east phenomenon?
It's the due east phenomenon.
This is one of the most elegant pieces of celestial geometry, I think. Because the Earth is neither tilting toward nor away from the sun during the equinox, the sun is positioned directly above the Earth's equator.
Right. But the notes say that because the sun is over the equator, it rises due east and sets due west absolutely anywhere on Earth.
That's right.
Whether you are standing in New York or Tokyo or a tiny island in the Pacific. See, I have to push back on this, or at least ask for the geometric explanation.
Fair enough.
Because if I am standing way up in Alaska, right, and someone else is standing on the equator, how can we both look due east and see the exact same solar alignment? We are on entirely different curves of the sphere.
It is counterintuitive until you visualize the celestial sphere.
Okay, help me visualize it.
So imagine a massive invisible dome surrounding the Earth. The Earth's equator projected out onto that dome is called the celestial equator.
Okay, I'm with you.
On the equinox, the sun is traveling exactly along that line. Now, no matter where you are standing on the surface of a sphere, the celestial equator always intersects your local horizon at exactly 2 points.
True east and true west.
True east and true west.
Okay, so it doesn't matter how high or low my latitude is.
Yep.
Because the sun is walking that specific tightrope across the middle of the planet, the geometry dictates it has to cross my horizon at those exact cardinal points.
Precisely.
Yeah.
Now, if you are in Alaska, the sun's path across the sky will look lower and more angled than it does for someone in Ecuador.
Oh, sure.
But the exact point where the sun breaches the horizon in the morning, that will be due east for both of you. It's a unifying geometric reality for the entire globe.
Okay, that makes the logistics clear, but my brain is still catching on the timing of it all.
How so?
Wait, how can this happen at the exact same moment everywhere if we're all living in entirely different time zones?
Right.
Like when I am having my morning coffee, someone in Australia is asleep in the middle of the night. So how do we reconcile our local time with a simultaneous global event?
Well, if we connect this to the bigger picture, we have to recognize that human time zones are just a localized administrative tool.
Like a filing system.
Exactly.
Yeah.
We created them so that the clock on the wall roughly matches the position of the sun in the sky for our specific town. We sliced the rotating globe into hourly blocks just for convenience.
Right.
But the equinox isn't about the Earth's daily rotation. It's about the Earth's position along its yearly orbital path around the sun.
Oh, I see. It's a point in space, not a time of day.
Exactly that. The equinox is a singular milestone on our orbital track. It is the precise second the center of the sun crosses the celestial equator.
Wow.
The entire planet hits that finish line at the exact same moment. Your local clock might say 8:00 a.m. while someone else's says 3:00 p.m., but you are both riding the same spaceship, crossing that exact threshold in the solar system simultaneously.
And because this mathematical movement is so objective and, well, universally observable, humanity has been obsessed with tracking it.
Oh, obsessed is the right word.
Yeah. I mean, long before we had atomic clocks or orbital satellites, ancient peoples watched the sun's pathway with a level of dedication that we really struggle to comprehend today.
Absolutely, because they recognized that identifying this specific point in space was critical for survival.
It told them when the planting seasons would begin and when the weather would turn.
And some cultures went to monumental extremes to capture that solar movement. The sources point as specifically to Morelos, Mexico, and the architectural mastery of the Mayans.
Yes, we are talking about the Temple of Quetzalcoatl.
It's just incredible.
It is. Around 1000 A.D., they built this massive, imposing stone pyramid to serve as a physical representation of the spring and fall equinoxes.
Mm-hmm.
And they engineered it so precisely that it interacts with the sun in a way that feels almost cinematic.
The visual phenomenon is known as the descent of Kukulkan.
Right.
It is a breathtaking optical illusion created entirely by celestial geometry, stone terraces, and the specific declination of the sun.
Here's where it gets really interesting, because your sources include visual evidence we can still observe today.
Yeah, you can go watch videos of this right now.
Exactly. If you stand at the base of this pyramid on the exact afternoon of the equinox, as the sun begins to set, the light hits the northwest corner of the pyramid's terraces.
Right.
And the terraces cast a series of triangular shadows against the edge of the main staircase. As the sun drops lower, these triangles of light connect, and it looks exactly like the body of a massive illuminated snake slithering down the steps.
So vivid.
And it ends perfectly at the base, where the Mayans carved a massive stone serpent head.
Which represents Quetzalcoatl, or Kukulkan, the feathered serpent deity. In their mythology, this god was a creator figure, deeply tied to the wind, the dawn, and the revitalization of the earth.
So to witness this deity seemingly descend from the heavens.
Animated by the sun itself.
Right. On the exact day the seasons shift, the cultural and spiritual impact would have been profound.
Oh, beyond profound. And think about the mathematical genius required to pull that off.
I look at this pyramid and it basically functions like a massive, high-stakes solar projector.
That's a great comparison.
But unlike a digital projector, you can't just adjust the lens if the image is blurry.
No, not at all. The margin for error is essentially zero. To create that serpent illusion, the Mayan architects had to calculate the exact angle of the sun's rays on the equinox.
Out of stone.
Out of stone. They had to determine the precise height and depth of the terraces, and they had to orient the entire structure along a very specific axis.
Wow.
If the base of the pyramid was rotated even a fraction of a degree, or if the terraces were just a few inches too tall, the shadow wouldn't form the triangles. You would just get a jagged, meaningless shadow.
It requires an awareness of the cosmos that feels incredibly distant from our modern lives.
Yeah.
I mean, they were dragging tons of limestone to build an instrument that proves the planet has reached its point of equilibrium.
It's a huge endeavor.
But while the Mayans were building these massive stone calendars, the notes highlight that other ancient cultures found far more delicate, intimate ways to engage with the physics of the equinox.
Yeah, the sources bring up the ancient Chinese tradition of the egg trick. Right. It's a piece of folklore suggesting that on the exact day of the spring equinox, you can balance a raw egg perfectly on its end.
I love this because it's basically a centuries-old viral challenge.
It really is.
The notes mention that there are modern videos right now of people standing in their kitchens on the first day of spring, meticulously trying to balance eggs on their countertops.
Oh, my feed is full of them every March.
But we need to explore the underlying logic here. The folklore implies that because the Earth and the Sun are in this perfect alignment, the gravitational pull somehow shifts to make balancing the egg possible.
Right, that's the claim.
So is there any actual orbital physics to that, or is it pure myth?
Well, this raises an important question about how folklore attempts to explain physics. The short answer is, the orbital alignment does not change local gravity enough to help you balance an egg.
Okay, myth busted.
Yeah, the gravitational pull of the sun on a chicken egg on your kitchen counter is completely negligible compared to the gravitational pull of the Earth itself. The equinox doesn't temporarily suspend the laws of physics.
So, if it's not a shift in gravity, why does the tradition persist?
Yeah.
Why do people actually succeed in balancing the eggs on this specific day?
It really comes down to microscopic textures and human psychology.
Really?
Yeah. An eggshell isn't perfectly smooth, right? If you look at it under a microscope, it's covered in tiny bumps and ridges.
Oh, sure.
So if you have enough patience, you can find 3 tiny bumps on the bottom of the egg to act as a microscopic tripod.
A microscopic tripod, wow.
Furthermore, the yolk inside a raw egg is suspended in fluid. If you hold it steady long enough, the heavier yolk settles to the bottom, which lowers the center of gravity and makes it easier to balance.
So the real magic isn't orbital gravity at all. It's just that the equinox is the one day of the year people actually have the patience to stand at their counter for 10 minutes experimenting with the center of mass of their breakfast.
Precisely. The physics of balancing an egg are the exact same on March 18th as they are on August 4th.
That is hilarious.
But the tradition endures because it's a tangible, physical way to engage with the concept of planetary balance. It brings this massive, abstract solar mechanic down to something you can literally hold in your hand.
That's beautiful, actually.
Mm-hmm.
It also perfectly ties into the universal symbolism of spring, because whether it's a descending serpent bringing life back to the soil or an egg representing fertility, spring is fundamentally about rebirth.
Exactly. Rebirth and renewal.
And the notes highlight the natural biological signs that people have always looked for to confirm this shift. We start seeing baby animals, cows, ducks, and birds having their young.
The arrival of bluebirds.
Right. The bluebirds return.
Yeah.
The freezing winds are replaced by gentle breezes.
And remember, before humanity had access to meteorological data and satellite imaging, people relied completely on these localized biological events to predict how the season would unfold.
Well, they had to.
They developed folklore and specific sayings that function as a survival guide for agriculture.
The sources mention several of these sayings, like the classic, April showers bring May flowers.
Right, we all know that one.
But the one that demands a closer look is the dandelion method. The folklore states that if dandelions bloom early in the spring, it indicates a short season. If they bloom late, you should prepare for a dry summer. So are these sayings just random guesses, or is there a biological mechanism making the dandelion a reliable weather predictor?
There is actually a robust biological foundation for this, and it's rooted in a field called phenology.
Phenology.
Right, which is the study of cyclic natural phenomena. Plants don't look at calendars. They operate on what biologists call degree-day accumulators.
Okay.
They are constantly tracking the temperature of the soil and the ambient air. A dandelion will only bloom when the microclimate it lives in has absorbed a specific amount of cumulative heat.
So the dandelion is essentially acting as a localized biological thermometer and data logger.
Exactly. If the dandelions bloom unusually early, it means the soil temperature warmed up very rapidly, suggesting a fast, aggressive transition into summer.
Oh, wow.
If they bloom late, it means the soil remained cold and dry for an extended period. And since deep soil moisture in the spring often dictates how resilient crops will be in July, a late dandelion bloom could indeed correlate with a tough, dry summer.
That is wild.
Ancient farmers didn't need to know the term phenology to recognize the causal link between the weed in their field and the viability of their harvest.
It's an incredible level of environmental awareness. It really is like an ancestral weather app.
Totally.
But not all of the folklore is purely agricultural, is it? Some of it feels deeply psychological.
Like what?
Well, the notes mention this old rule. Don't say that spring has come until you can put your foot on 9 daisies.
Oh, yes. The specificity of 9 is very telling.
I think it perfectly captures humanity's deep, almost desperate desire for certainty after a harsh winter.
Oh, absolutely.
Right. If you see just one daisy, it could be a fluke.
A false spring.
Exactly. The soil might have had a weird warm patch. You can't declare victory over winter based on one flower, because a late frost could still arrive and wipe out your crops.
You need 9 daisies.
You need 9 daisies.
Yeah.
You need a critical mass of biological evidence beneath your foot to finally exhale and trust that the famine of winter is actually behind you.
That psychological need for proof really highlights how completely intertwined human survival used to be with these seasonal shifts. Finding those 9 daisies wasn't just a pleasant observation on a nature walk.
Right.
It was the literal confirmation that the Earth was providing again.
And today, we are so heavily insulated from those stakes.
We really are.
We have central heating, and we can buy fresh strawberries at the grocery store in January.
Yeah.
We don't have to wait for the dandelions to log the soil temperature because we can just look at a 10-day forecast on our screens.
Which is exactly why the sources specifically recommend using the arrival of the equinox as an opportunity to consciously re-engage with that physical reality.
Yes, and I want to put the questions from your notes directly to you, the listener.
Go for it.
The sources ask, are you noticing the days getting longer? When you wake up, is the quality of the light different?
Can you hear the birds singing when you walk to your car?
Are you hungry for summer after a long winter?
It is an invitation to step out of our modern convenience for just a moment, to deliberately go outside, observe the new growth in your own environment, and perhaps share your favorite signs of spring with your family and friends.
Yeah.
To actually pay attention to the data your environment is offering you.
It's about putting down the phone and maybe looking for those 9 daisies yourself, feeling that subtle shift in the air that tells your brain the planet has reached its equilibrium.
And to leave you with a final thought to mull over as you do that, consider the vast scale of the mechanics we've discussed today.
Okay.
We know the equinox is an objective point in space, right? Happening simultaneously for everyone on Earth.
Right, crossing the celestial equator.
Exactly. So we can picture the ancient Chinese citizen carefully balancing their egg and the Mayan architect watching the shadow of the feathered serpent descend.
Oh, wow.
Both participating in the exact same mathematical alignment of the solar system, united entirely by the sun hitting the equator.
2 entirely different cultures. Two different people participating in the exact same second of celestial geometry, completely unaware that the other even existed.
Isn't that profound?
That is incredible. So when you step outside today and you feel that bitter edge of winter finally break, remember that you are experiencing something that connects us all. You are standing right on the precipice, perfectly balanced for just a moment.
Thank you for joining us for this day in His story. May the lessons of yesterday inspire you to see God's hand today and to play your part in His story now. For more faith-based learning, visit ahsworldwide.org, the homeschool for faith and family.